All right, so some of you asked about the solutions to the problems from day 35. So this is day 35. I got an upset baby. So for day 35, number 2, dragging the box full of books. Um, you can set the forces equal to each other in the x direction and in the y direction. Use the force of friction equation, do some substituting, and get your solution to 2 sig figs. For number 3, you've got a 52 Newton sled, the coefficient of friction, and you know that there's a person weighing 650 newtons that's on the sled. So basically the only tricky thing with this sled is that you have to add together the weight of the sled and the weight of the person to get 702 newtons, and then just solve the force equation. And again, the force applied and force of friction in this problem are balanced because it is moving at a constant speed. So that's those. 4 was a lot harder. So if you want, you can just take a look at it. That's the problem and the solution. I'll run you through how I got the answer. So 4 says that you've got Derek playing cards, gives the mass of the card, says how far it slides. I converted the mass into kilograms, displacements in meters, got mu, and we don't know the initial velocity, we know the final velocity is 0. So there's a lot of steps to this. But basically the first thing you do is sum the forces to get your relationships. We know the force of friction is equal to mass times acceleration in the x direction. We also know the force of friction is equal to mu times the normal force. So we can put those two things together, right? Set the forces of friction equal to each other. And now we can start doing some substituting. Well, actually, that was substituting. Now we can do more substituting. The normal force is equal to the force of gravity, which is mg. So I'll do that substitution. And now everybody brought mass to the party. Ha ha ha. And so we can cancel mass. And so we get this relationship with acceleration, mu, and gravity. The issue is we don't know what the acceleration is,